Humans have looked up at the night sky and wondered, are we alone? Enter the void.
In our last cosmic journey, we scaled the entire universe, and what we found was humbling. But there are objects out there that challenge not just our understanding of space, but reality itself. They're called black holes. And everything you think you know about their size is probably wrong. Because what if I told you some black holes are so small they could hide inside an atom, while others are so colossal their shadow could swallow our entire solar system? Today, we take the definitive journey from the smallest to the largest. This is the true scale of black holes. Let's start with the smallest. In theory, primordial black holes could exist. They aren't born from dead stars, but from the dense fluctuations of the infant universe. Imagine them the size of a proton, but with the mass of a mountain. They are theoretical ghosts, nearly impossible to detect. But if they exist, they would revolutionize physics. This is what we know. When a massive star dies, its core collapses. If it's heavy enough, nothing can stop it. A stellar mass black hole is born. Take the famous Cygnus X1. Its mass is 21 times that of our Sun. But all that mass is compressed into a sphere just 124 kilometers in diameter. To put that in perspective, the mass of 21 suns crushed into a space smaller than the length of Florida. The gravity here is so extreme, not even light can escape. But this is just the warm-up. At the heart of nearly every galaxy, there sleeps a monster, a supermassive black hole. Ours is called Sagittarius A star. It has the mass of 4.3 million suns. And yet, its event horizon would fit inside the orbit of Mercury. Remember when we compared Earth to the Sun, and the Sun to other stars? Apply the same logic here. If the stellar black hole Cygnus X1 were the size of a marble, then Sagittarius A would be the size of a soccer ball. A vast difference, yet still contained. But there is a final tier, a tier that redefines colossal. The black hole at the center of galaxy M87, the first humanity ever saw directly. Its mass is 6.5 billion suns. Its shadow is larger than our entire solar system. Literally, if we placed it where our sun is, it would swallow Pluto. And there are others even larger. But size alone is just half the story. What truly defines a black hole isn't just its mass or the space it occupies. It's the absolute dominion it exerts over the fabric of reality itself. Its gravity. Think of space-time as a flat, stretched rubber sheet. A planet like Earth creates a small dent. A star like our Sun, a deeper one. But a black hole doesn't just make a dent. It punches a hole straight through the sheet. This isn't a dip. It's a bottomless pit. And the steepness of its walls at the edge, the event horizon, is what we measure as surface gravity. And here's where scale becomes terrifying. For our theoretical primordial black hole, smaller than an atom, the surface gravity is unimaginably fierce. Its gravity well is like an infinitely sharp needle. If you could get near it, which you can't, The difference in gravity between your head and your toes would shred you apart in a nanosecond. At this scale, the laws of quantum mechanics and gravity collide, a mystery we still can't solve. Jump to our stellar black hole, Cygnus X1. Its gravity well is vast and deep. This is the realm of spaghettification. Get too close, and the pull on your feet is billions of times stronger than on your head. You wouldn't just be crushed. You'd be stretched into a stream of atoms thinner than a strand of DNA, spiraling into the void. Now, behold the supermassive black hole. Its event horizon is so vast, so gradual, that you could theoretically cross it without immediately noticing the point of no return. But make no mistake, its power is godlike. It doesn't just consume stars, it orchestrates galaxies. It heats matter to millions of degrees, creating quasars, the brightest objects in the universe. It bends light into perfect rings, like the one we saw in the M87 image. It is the ultimate cosmic architect. So, when we talk about scale, we must talk about consequence. The tiny one hides a violence so extreme it breaks our physics. The stellar one is a relentless destroyer of matter. And the supermassive one is a celestial engine that can birth new stars and shape the fate of its entire galaxy. Size isn't just about measurement. It's about the degree of control over the universe itself. So, this is the scale. From a subatomic ghost to a leviathan that rules galaxies. Each one is an extreme manifestation of the laws of physics. A window to where space and time cease to make sense. Understanding their size isn't just a numbers exercise, it's a lesson in humility. It reminds us that the most powerful forces in the cosmos can be hidden in infinitesimal points or reign from invisible centers. And the most fascinating part? We're only just beginning to understand them. If this journey through the scale of black holes left your mind in pieces, then the first journey, where we scaled the entire universe, is waiting for you right here. And if you want more explorations like this, subscribe and hit the bell.